Hello students. So let's now look at the second question. It was asked in GATE-CS 2015 and again checks your basic understanding of the BFS. Slightly tricky, although it looks intimidating if you read the question. So let me read a question and let's try to solve it. And one more thing I would like to tell you. So in these kind of questions, try to build a very simple case first, right? Then run through the question. You'll get an idea that what examiner is trying to ask. And then try to increase the complexity, consider all the cases, and especially in this kind of question where they're checking about something which is true, something which is not true, multiple choice questions, checking the boundary conditions. Once you draw a simple, very simple, version of the question, then you can try to, see that what cases you can reject outrightly, right? And then try considering all possible cases and then verify your answer. You need not to prove anything because see, time is also a constraint, right? So for example, let's see how we'll do that in this question. So G is a undirected, unweighted graph. X is any of the vertices, any of the vertex in the graph, and dx denotes the shortest distance of that vertex from a source S. Now BFS is performed on G. T is the resulting BFS tree. So what is the BFS and DFS trees? So these are the graphs which is obtained once you run the BFS or DFS algorithm on the mother graph, right? And these are trees, right? So what do we mean by tree? That there are no loops in them, right? So in a BFS tree or a DFS tree, there would be no loop. It would be a loop-free graph, right? And if u comma v is an edge in G, right? It was an edge in G, u comma v. U and v are the two vertices, but it is not in T. So what does that mean? That means if we introduce that edge in T, it will create a loop, definitely. That's why it's not there, right? And which is not true for du, that is the shortest distance from source S to U, minus dv, shortest distance of V from source S. Which of the following is not true? So let's try building, let's take a very simple case, right? And then try to increase the complexity and get to the answer. So for example, since he's asking about the BFS tree, so let me take a very simple tree. Let's say, and let's take the binary tree. Let's say it's E, right? So let's assume that this was our binary tree which we obtained after running BFS onto this graph, and this was my source node S. And for the sake of simplicity, let me take this as U and vertex V. Fine. Let me also take, just because there were some edges, now U comma V is not in the BFS tree, but it was earlier, so let me mark it by dotted line. So this was the part of the original graph G, and let me make another edge also just to increase the complexity. Now what it says that which of the following is not possible, right? So in this case, what is du? So du is the shortest distance from the source, right? And also let's try running BFS first of all on this graph. So what will happen? A will be visited, A will be put into the queue. Two neighbors of A are B and C. A would be taken out, B and C are pushed into the queue, mark as visited, right? Now B is taken out. When B is taken out, its neighbor are analyzed, D and C. Since C is already in the queue, we'll push D. Then we'll take out C from the queue, right? You can watch my previous lectures. It is given in, the method is given in quite detail there. Now what will happen? You'll come to C, see all the neighbors of C which are not been visited. So there is only one E. So you push E into the queue. Then finally, and mark it as visited. Then finally you take out D, and finally you take out E, right? So this is the procedure, right? So from B, C will not be visited, right? So we'll not take this edge into our finally BFS tree. And from here again, this edge will not be in our final tree. Why? Because from D, C is not visited. C had already been put into the queue through right? Now let's come. So in this case, what will be my du? So my du in this case will be 1, and my dv in this case would be again 1, and that is perfect case, right? So, and u comma v is not there, so it means that what will be my du minus dv? So du minus dv will be 0. So this means now this is not my option because it is possible. Okay, fine. Now let's see that what if u would have been this vertex, right? So if my u is this one, so now what would be my du? Du in this case would be 2, again dv is 1, and again I have not included this edge, right? U comma v is not in the final graph, final BFS tree. And why? You know the reason, right? Because C, you discovered C and you did not discover C from D or D from C, right? So this is another perfect case for us. So is it possible? Yes. So du minus dv is 1, right? And also, right? And also we can just reverse the condition, right? Just flip the graph mirror wise. So it means that dv could have also been 2 and du could have also been 1, right? So du minus dv in that case would have been minus 1, right? Because this is one of the graphs which I have taken. There could be any graph, multiple variation of this, right? So it means now that these are also possible. So these are also not part of my answer. Now what is happening? Now what, see, if you have a paucity of time, you can just mark 2 and move ahead. But now we'll analyze why it is not 2, right? Because we are giving solution to this question. So now what will happen? See, let me take an example. Let me give you a brief intuition why it cannot be 2. So let me add another note here, F. Fine. So let's say if this was this H from F to C, which I have not included in my final BFS, right? So from A to F, what would have been my distance? 3, and here definitely 1. That's why my answer was 2, right? But would it be possible? No. Because why? See, because I am saying that 3 is my shortest distance, right? But I myself will be contradicting because I can reach F from S via shorter route. What that route would have been? So that route would have been nothing but this route, right? Because the distance from this would have been what? 2, right? So I hope you are now getting the intuition that, see, now you can also prove it formally that, see, if D and V are the shortest distance from a source, right, and there is an edge, right, and definitely what will be the value of traversing this edge? That is 1, right? So if the difference, right, between these two, right, is more than 2, right? So suppose if we say that D is, let's say, 5 and this is 2. So DU could not have been the minimum distance from the source, because then you have an alternate path. You could have come from here and here, right? So in this case it will be dV plus 1, right? So the maximum distance, maximum difference between the two shortest paths could be either 1, 0 or minus 1. Are you getting this point? Because if it's more than 1, then definitely you could reach D via V, and that distance would be dV plus 1 or the vice versa, right? So if you again find it difficult, just go through it again and I'm sure it will be clear to you, right? So my answer would have been in this case 2. Thank you very much.